formula.
Time is positive.
Well, we assume that change in time is positive.
Okay. Right. That was
And velocity changes.
All right, now let's put these ideas together.
And the velocity increases.
And the change in velocity is positive?
There we go. I'm not sure what velocity increases means. If I go from negative 10 meters per second to positive 5 meters per second, I've slowed down, but it's a positive change. So is that an increase in velocity or a decrease?
It slows down.
Yeah, it's slowed down, but it's positive acceleration.
Yeah.
But where most people get stuck here is they think in terms of, is the velocity positive or not? It's not the velocity, it's the change. Change in velocity is key here. So if change in velocity is positive. Now, the other way of dealing with acceleration, as we'll get to in chapter 4, there's very much a relationship between acceleration and force. So if I'm walking in the negative direction, again, going with that convention that I established earlier that Wesley spoke of. If I'm traveling in the negative direction and I'm pushed in the direction I am moving, will I speed up or slow down? I'm moving in the negative direction and I'm pushed in the negative direction.
You know,
All right. My acceleration will be in the same direction as the total force. That's a chapter 4 concept. So if I'm moving in the negative direction and I push in the negative direction and I speed up, well, I speed up because I push in the direction I'm going. So another way of looking at this, just an alternate way, is speeding up the velocity and acceleration have the same sign. If slowing down, velocity and acceleration, opposite signs. From a physics point of view, if you are forced in the direction you're moving, you'll speed up. If you're forced opposite the direction you're moving, you will slow down. Questions to hear before we do the plus minus zero exercise? Which I don't think I have on video. I do a plus minus zero with the ball in the air and there's a PowerPoint, but this is the classroom plus minus zero exercise. It's going to be some audience participation. Answering correctly in unison will bring tears of joy to my eyes. I look forward to it. For the sake of this, I'm going to make this my starting point. And I am going to make this the origin. Just so that we're all on the same page, I'm going to make it to the right positive. Why is to the right positive?
Because
you said so.
Absolutely. All right. Right now, my position, positive, negative, or zero.
Negative.
Wow, so in unison, it sounded like a single voice. But that's how the game is played. All right, my displacement.
Zero.
My starting point's over there.
Oh, negative.
All right, there we go. My velocity,
Zero.
my acceleration.
Zero.
Okay. I start to move. My velocity,
Positive.
my position,
Positive.
displacement,
Positive.
my position,
Positive.
displacement.
Positive.
Negative.
No, it's still positive.
Positive, yeah.
Sorry, I had a brain blip. My velocity,
Negative.
acceleration.
Negative. Positive.
I was hoping to go the same speed in the same direction. That was supposed to be zero. Some of you are very sensitive to my movement, or It should have been 0.
The acceleration should have been 0?
Right.
Yeah, if my velocity was constant,
The zero.
my acceleration would be 0. Velocity doesn't change, acceleration is 0.
Yes.
All right. My velocity,
Positive.
and then my acceleration as I'm stopping.
Negative.
All right. My velocity,
Positive.
Negative.
it's negative. I'm going in the negative direction.
Yeah.
Try that again. So my velocity,
Negative.
as I'm stopping, my acceleration,
Positive.
indeed.
Yes.
Some people think you're slowing down. It's negative acceleration. No. I slowed down, so my velocity would be opposite of my acceleration using this rule. Or from the point of view of change in velocity, if my velocity is negative 10 meters per second, and then it goes to 0, well, negative 10 to 0, is that a positive change or a negative change?
Positive.
Indeed. Think of a number line. I got a classic number line. I got 0 here, I got negative 10 here. The change from negative 10 to 0 is in the traditional positive direction. All right, so I'm moving in the negative direction. My velocity is negative. I stop and turn around. At that moment that I stop to turn around, and I will say, in a one-dimensional problem, if my velocity goes from positive to negative, or negative to positive, I have to go through 0. I can't go from positive to negative without going through 0. Without a rip in the space-time continuum. And that's out of scope for this course. And despite what some students make. All right, so I'm going, I have negative velocity. I stop, turn around. At the moment that I'm stopped and turning around, what is my acceleration?
The moment that you stop.
0.
At the moment that I stop.
Positive.
I got a positive and I got a 0.
Pop.
I have 2 positives and a 0. How many?
Well, if it's a change in velocity, you are changing your velocity at that moment. So you were moving, stop for an instant, and then you start moving again.
Yes.
So there is a change in the velocity during that point, right?
Yes.
Can I change my answer? Negative. Because you're slowing down, and if you're slowing down, so when it comes to velocity, it goes from a negative to a 0. There's a positive change, and since you're slowing down, it'll be a negative. It's going to be the opposite sign for acceleration. So it'll be a negative acceleration.
It sounded like you were on, and then suddenly you veered off of what you were saying. All right, we'll come back to that in just a second. So you were saying that my
Wait,
velocity was changing?
Your velocity is, saying even though it's like only for an instant, you were moving, you stopped moving, which is a change in velocity, because you go from moving to not moving, then you start moving again, so would it be positive? Because
Okay.
you're moving the whole time?
Definitely it's not 0. Because it does deal indeed with change in velocity, not the velocity itself. I'll do another argument for why it can't be 0. All right, now what Giovanni was saying, I'm moving in the negative direction and I slow down. So opposite signs.
Yes.
So my acceleration and that as I'm slowing down is
Positive. Positive.
I stop for an instant, I'm now moving in the positive direction. Because again, if I stop and then start moving in the positive direction, am I speeding up or slowing down?
Speeding up.
Yeah, if I'm going from stop to moving, I gotta be speeding up.
Yeah. Oh, no, it's because I thought you were going from like when you're going in the negative direction to stop, not from stop to going back.
Yeah, so when I'm going in the negative direction, slowing down, the acceleration is positive. When I go in the positive direction, speeding up is, the acceleration would be positive. And at the turnaround point, since there is still a change in velocity, it is still gonna be positive. Now, because saying it's 0 is a common mistake. If the acceleration is 0. So if, if acceleration is 0 when velocity is 0. Think about that. Acceleration is 0 means the velocity doesn't change. If the velocity doesn't change and my velocity is 0, that means I never move again. So if this were the case, then stopped objects. We'll pretend that's the word stop. Stopped objects never move again. Which we know is not the case. Another way of looking at it is I have velocity versus time. I have a positive velocity, I go to a negative velocity, I have to pass through 0, so this is the stopping point. This is when I stop and turn around. I know acceleration, excuse me. Acceleration is change in velocity over change in time. Well, if I have a velocity time graph, that's just the rise. If I take 2 points on here, my rise is my change in velocity, my run is the change in time. What is this? Math-wise, change in velocity over change in time in a velocity time graph.
Slope.
Yes. So acceleration is the slope of velocity versus time. And at this point right here, when I'm crossing 0, my slope isn't 0. What's the 0 slope look like?
Straight line.
That's a straight line.
Horizontal straight line.
Thank you. There we go. It's supposed to be a straight line. Similarly, velocity, change in position over change in time. So if I have a position time graph, velocity is the slope. All right, questions to here? Dominic?
Is there an instance where acceleration can be negative?
Oh, yeah, yeah. So I start out here at rest. Let's assume the same starting point and same origin. I start to move in the negative direction. So my velocity goes from 0 to something negative.
Oh, because the change of velocity is negative, the
Yes.
accelerating, okay.
Yeah. So it will benefit you in this course if you can basically internalize what Dominic just said about the change in velocity. And not whether you're speeding up or slowing down automatically. There are other factors. Other questions? All right, let's do a test level problem. I am assuming that you've already watched the ball being thrown into the air problem as part of Monday's this class. Time A, that's when the problem starts. At time B, this is when it turns around. It stops instantly from going the other direction. So this is stops for a moment. Turns around, comes back down, goes down that ramp, comes across here, So this, there is friction. That is just indicating that that's shorthand for the kinetic coefficient of friction is not zero. In other words, it's going to experience friction. So A, B, C, it's back at the starting point. D is passing by this point right here, which I'll explain in a moment. E, it is box first touches level surface. F, box last touches level surface. It comes up here, time G, box stops as it turns around. H, it's in the same position as F, just going the other direction. I, it's now passing the same point it was at point at time E, and then H, I, and then J, box stops. And it would turn around, but we're stopping the problem there. All right. So we're gonna express, for the time duration here, we're gonna express when are the big four quantities positive, negative, or zero. There are a couple of ways of displaying it. I'm gonna go for, well, first off, let's identify all the different time segments. I probably don't want to use this on that.
Quick question.
Yes?
Which way is positive?
Oh, and where's the origin is the other question you need to know. Let's make to the right positive, because Wesley has too much influence. And let's make the origin at time E and time I, the box is at the origin. Thank you. All right, so we're gonna deal with displacement. No. So we'll have position, displacement, velocity, and acceleration. There's going to be, we have time A, we have B, we have between A and B. We have to identify times in between as well. We'll have between B and C, C, between C and D, D, between D and E, E, between E and F, F, F to G, G to H, H to I to J, J. And on a test, I would provide this to you. All right. When you see the parentheses like this indicates that G is not included. So if I have the G, H in parentheses, that means between G and H, not including G, not including H. If I wanted to include G or H, I'd put a bracket, square bracket instead of parentheses. All right, so let's start out with the position. Where is the position equal to 0? At what time is the box at position equal to 0?
I/E.
Okay. So at E, it's at 0. And at I, it's 0. Okay. Because remember, I can't go through from positive to negative or negative to positive without going through zero. So if those are the only places where it's at the origin, then those are the only places I can switch from positive to negative. So when is it positive? When is the position positive?
A, B, C, and D.
How'd you get that?
Oh, wait.
Okay. Take two.
F, H, and G.
You said FHG?
Yeah.
What about the in-between times? What about between E and F? Yeah. It's not just at the times I mentioned there, it's also between the times I mentioned. Those are just key times. All right, so it's positive there. What about over here?
Negative.
Yeah. And over there?
Negative.
Yeah, because I'm on the negative side. Positive side is this way. Here's my origin. Anything over there is positive position. Anything over here is negative position. So negative, 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 negative. All right. Displacement. Where is displacement? Equal to 0. Or at what times is the displacement 0? And again, this is overall displacement because I didn't qualify it. Let's give.
A and C.
Say it again.
A and C.
Yep. Any other places? All right, let's pick up the pace. We're losing out.
Got 4 hours of sleep.
All right, so what about between A and C? Is displacement positive or negative?
Negative.